Welcome to video 3, Summation. This is the third video in our flipped installment on the sequences chapter. In the previous two videos, we focused on binomial expansion. This topic of summation we're doing in this lecture really is very unrelated to those, other than the fact that they're both, create a sequence of terms and then we do something with them. And the concept of sequences and going forward in the future, or the next videos after this, are going to get into different types of sequences called arithmetic and geometric and things we could do with those. But so that's why the whole chapter is called sequences, because everything we do kind of produces a sequence of terms, and something happens from that. In the previous stuff, it created polynomials. In this, we're doing summation, and summation, the beginning of summation is sum. And so we're going to create a sequence of terms, and then we're going to sum them together, which means we're going to add them together. Now, the symbol we use for summation is the Greek capital letter sigma. That's what this giant symbol looks like. It kind of looks like an E, I suppose, but it's a capital letter sigma. We've dealt with the lowercase letter sigma before when we did standard deviation. So this is capital sigma, and it's just the symbol that we use for this concept of summation. And how it works basically is best described by just kind of looking at an example. So if we look at our first example here, we see there's really things all around the summation symbol. There's something on the bottom, n equals 1, there's a number on the top, and then there's something to the right of it. The expression to the right of it, this 3n over here, that's basically the expression we're going to plug different values of n into. And so n is our variable, and we can replace n with any number we want and do 3 times that. That's what 3n means, 3 times n. But what we're going to do is we're going to start here. So whatever number is down here, this is where you start. And so write that there. You start with n equals 1. So the first number we're going to plug in for n is 1. Then we go up by consecutive integers, meaning we're going to go from 1 to 2 to 3 to 4 to 5 to 6, 7, 8, 9, 10, and so on. So you go up by ones. No matter where you start, you always go up by one number. And we're going to go until we end here. And so the number on top is where you end. So if we're starting at n equals 1 and ending at 4, that means we're going to plug in n equals 1, n equals 2, n equals 3, and n equals 4. And one at a time, we're going to plug those into our expression, 3n. So let's see what happens. 3n for n equals 1 is 3 times 1. 3n for n equals 2 is 3 times 2. 3n for n equals 3 would be 3 times 3. And 3n for n equals 4 would be 3 times 4. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. So 3, 6, 9, 12, that's our sequence of terms. And what we're going to do now is we're going to sum them together. That's why we call this summation. So we add them together. 3 plus 6 plus 9 plus 12. Now we don't need a calculator for this, but I'm going to get it out in case we do. 3 plus 6 is 9. 9 plus 9 is 18. 18 plus 12 equals 30. And so our final answer is 30. That's basically it. That's how you do summation. I'm going to do a couple more examples with you in this video, but that's essentially it. You have an expression to the right, in this case 3n, with a variable, and you're going to plug numbers into that variable one at a time, starting with whatever numbers down here and ending with whatever numbers up here, going up by 1, and you're going to get a bunch of terms, add them together, and that will be your final answer. In this case, the answer was 30. Okay, so let's try another example. So this one has this expression n minus 1 squared. So whatever we plug in for n, we're going to minus it by 1, and then we're going to square it. We're going to start at 0, and we're going to end at 5. And so that means we can say n equals 0, n equals 1, n equals 2, n equals 3. I'm going to run out of space here, but that's okay. N equals 4, and n equals 5. And so one at a time, let's plug that in. That's going to be, instead of n minus 1 squared, 0 minus 1 squared, 1 minus 1 squared, 2 minus 1 squared, 3 minus 1 squared, 4 minus 1 squared. Because remember, what I'm plugging in is I'm just replacing n with these numbers. And so the last one for 5 would be 5 minus 1 squared. And so now you need to evaluate these. 0 minus 1 is negative 1 squared, and negative 1 squared is positive 1. Remember, negatives raised to even exponents become positive. 1 minus 1 is 0 squared, and 0 squared is 0. So I'm going to have 1 plus 0 plus 2 minus 1 is 1 squared. 1 squared is 1 plus 3 minus 1 is 2 squared. 2 squared is 4. 4 minus 1 is 3 squared is 9. And the last one down here, 5 minus 1 is 4 squared. We're going to get 16. So I'm just going to rewrite all those. That's 1 plus 0 plus 1 plus 4 plus 9 plus 16. And what does this sum out to be? 1 plus 0 is 1, plus 1 is 2, plus 4 is 6, plus 9 would be 15, plus 16 equals 31. Okay, one more example. And this one's a little different because you notice that there's stuff to the front. All of our other examples, we have our start on the bottom, our end on the top, and then our expression to the right. But what happens when we have stuff on the left? Well, basically, the stuff on the left you deal with at the very end because this is still what we're focused on. Anything to the left of your summation symbol is applied to the final sum. Like our answer here is 31. If we had like a 5 plus over here, we do 5 plus 31. It doesn't get applied to each term. It applies to the final summation. And so you can read this kind of like, if we ignore this 10 plus, 10 with nothing between this. Remember, when there's nothing between things like 5n, that's 5 times n. So this is 10 times summation of this whole process. So we're going to do this whole process, and whatever we get at the end result as our summation, we're going to multiply it by 10. And then 3 plus that is 3 plus that. So basically, anytime there's anything over here on the left side of your summation symbol, you don't deal with it until you're done with everything we've been doing. So we have this expression, n squared minus 5n. So there's 2 places of n we're going to substitute numbers into. And we're going to go from 2 to 6. So starting at 2 and ending at 6. So that's 2, 3, 4, 5, 6. So n equals 2, n equals 3, n equals 4, n equals 5, and n equals 6. Now, one at a time, I'm going to plug that into, whatever I plug in for n, I'm going to square it, and then minus 5 times it. So this would be 2 squared minus 5 times 2. Because n squared minus 5n with n is 2 is 2 squared minus 5 times 2. And this one is 3 squared minus 5 times 3. 4 squared minus 5 times 4. Remember, if I write faster than you could always pause the video. 5 squared minus 5 times 5. And 6 squared minus 5 times 6. And let's see, what do these come out to be? The 2 squared is 4, minus 5 times 2 is 10. 4 minus 10 is negative 6. 3 squared is 9, minus 5 times 3 is 15. 9 minus 15 is also negative 6. 4 squared is 16. 5 times 4 is negative 20. 16 minus 20 is negative 4. So I'm going to have a lot of negatives here. That's okay. 5 squared is 25. Minus 5 times 5 is minus 25. That is 0. And so I wouldn't be surprised if I end up with a positive over here. 6 squared is 36. Minus 5 times 6. 5 times 6 is 30. 36 minus 30 is positive 6. And so let's see here. Did I make any mistakes? 4 squared, 2 squared is 4. 4 minus 10 is negative 6. 9 minus 15. 3 times 15. 9 minus 15 is also negative 6. 16 minus 20, negative 4. So I think I'm okay. This is the problem with the videos. If I make a mistake, there's nobody in class to point it out. So let's add them up. Negative 6 and negative 6 is negative 12, and negative 4 would be negative 16, plus 0 is nothing, plus 6 gives us a summation of negative 10. Again, if I'm not really sure, I could do that on my calculator here, but I'm pretty sure that's it. That's negative 12, negative 16 plus 6 is negative 10. But remember, now I have to apply all this stuff. So it's like 3 plus 10 times what I got of negative 10. That's 3 plus 10 times negative 10 is negative 100. 3 plus negative 100 is negative 97. And that's my final answer. So we'll practice this tomorrow. See ya.